Behavior has made every observing session critical, because data can change in just a matter of hours. Astronomers quickly calculated the path of 3I Atlas, and the timeline they mapped out became one of the most important parts of the mission. The comet would reach its closest point to Mars on October 3, 2025, passing close enough that orbiters around the red planet could get a direct view. Then, only a few weeks later, on October 30th, it would reach perihelion, the closest point to the Sun, at about 206 million kilometers, which is just inside the orbit of Mars. Unfortunately, during this period, the comet would be on the far side of the Sun relative to Earth, making it nearly impossible to observe directly from our planet. This was a frustrating reality, but scientists knew that patience would be rewarded. By early December, 31 Atlas was predicted to reappear from behind the Sun, giving astronomers another chance to observe its coma and tail before it began to fade. On December 19, 2025, the comet would reach its closest approach to Earth, at a distance of about 1.2 astronomical units, or 180 million kilometers. While this was still far away, it was close enough to allow detailed monitoring using some of the largest telescopes on Earth, as well as instruments in space. After that, the comet would continue its journey outward and likely remain visible to powerful telescopes until sometime in 2026, before disappearing forever into interstellar space.
It's moving at a velocity of about 135,000 miles per hour, so it's going really fast.
The significance of these dates cannot be overstated. Each one represents a unique opportunity to capture information about the comet's structure, its chemical makeup, and the way its activity evolves over time. Unlike objects native to the solar system, interstellar comets like 3I Atlas give us only one chance to observe them. Once they leave, there will never be another opportunity. That urgency has pushed the scientific community to coordinate observations across continents, ensuring that not a single window of visibility is wasted. But perhaps the most fascinating aspect of all is that its behavior is still unpredictable. Some nights it shows a thin tail, while on others it appears strangely quiet, as if hiding its true nature. That mystery has led to the next big question. How does 3I Atlas compare with the two famous interstellar objects that came before it? Before Comet 3I Atlas shocked the world, in 2025, astronomers had already encountered two interstellar visitors that completely changed how we look at the universe. Each one carried its own mystery, and together they set the stage for why 3I Atlas is so important today. The first was Oumuama, discovered in October 2017 by the Pan-STARRS telescope in Hawaii. Its name means scout in Hawaiian, and that description could not be more accurate. From the very beginning, Oumuama did not behave like anything seen before. It shot through the solar system on a hyperbolic path, confirming that it came from beyond the Sun's reach. But what truly surprised scientists was not just its speed or trajectory, but its strange physical features. Observations suggested that it had either an extremely elongated shape, like a giant cigar, or possibly a flat pancake-like form. No asteroid or comet in the solar system had ever looked like that. Even more puzzling was its acceleration. After passing close to the Sun, Oumuama sped up slightly, but telescopes could not detect any visible tail or gas emissions that would normally explain such movement. Comets usually gain speed because of jets of vapor escaping from their icy surfaces. Oumuama showed none of that. This unexplained acceleration led to wild speculation, including the controversial idea that it might be an alien probe or even a light sail, a type of spacecraft powered by starlight. Most scientists eventually dismissed the alien theory, pointing instead to unusual outgassing or surface effects, but the truth is that the object remains unsolved to this day. Just 2 years later, in 2000,